Hello and good evening to everyone. Welcome to another lecture on your Resultant AJ YouTube channel. So I'm back again with a very important lecture on mixed question marathon of mechanical engineering on Resultant AJ YouTube channel. So I'm back again. This is Monday. Again, a new series is going to start from today. So very good evening to everyone. Just write in the comment box whether my audio and video is fine or not. Yes. Good evening everyone, good evening, welcome to the session. Please let me know if my audio and video is fine and you are getting a clear audio and video. Yes everyone, please confirm me about the audio and video quality so that we can start with the session. Yeah, hello Sagar Kumar, good evening, welcome to the session. MS, good evening. So good evening everyone, welcome to the session. I hope everyone is fine and my audio and video is fine, and let's begin the session. Also, I want to tell you about one very important thing that on 7th and 8th of September, a scholarship test was conducted. I hope that many of you must have given that or attempted that scholarship test. Those students who are waiting for the result of the scholarship test and waiting for the scholarship that you will be getting if you will perform well. My dear students, the results of the scholarship test will be announced tomorrow, and for that you need to check the telegram. Okay, please join the telegram of Resultant AJ Civil and Mechanical telegram. On that telegram we will announce the result, and those who are going to get good marks in the scholarship test, that is top 3 rankers, will get 90% scholarship. Then accordingly up to 75 rank we are providing scholarship. Okay, so just wait for the telegram, wait for the message in the telegram for tomorrow, and if you have given the scholarship test you will definitely get a huge scholarship from our side, okay, on our courses. Hello Subhash Raja, good evening, welcome to the session. So let's begin the session, and good evening once again. Those who have joined me for this session, please take out few seconds to subscribe the channel and press the bell icon which is next to the subscribe button. Also take out few seconds to share the session with your friends who are preparing for RRB JE or any other exams which are technical exams. Okay, so this is basically a mechanical engineering class. At 8 PM we are providing you mechanical classes. Okay, हिंदी में समझाते तो अच्छा होता, समझ में आ जाता है. Yes, that is correct Subhash, but on this platform we provide the classes in, we generally provide the classes in English language. Okay, so the reason is very simple, that Hindi is the language which is understood by it may be a language which is understood by some people, but English is a language as you know that is even whole country, if the students are from any states of the country or any union territory, they can easily understand the English language. So that's the reason we are providing these classes or conducting these classes in the English. Okay, this is my introduction. Those who are meeting me for the first time, my name is Vikas Sir. I am a faculty of mechanical engineering, having 7 years of experience teaching for different subjects of mechanical engineering, fluid mechanics and applied from the last 7+ years. I have done my MTech in thermal engineering from Thapar University and mentored more than lakhs of students for these examinations. Okay, I hope my audio and video is fine and you are getting clear audio video, and there is no problem in that. Let's come to question number 1. Just a second. Let me see if there is some kind of buffering. Is there any buffering in the session? Just a second. Some issue every time I see in the mobile phone, it's not showing the exact. Okay, I think there is some lag here. Are you getting the is the question visible to all of you? Now we are on the first question. I hope it is visible to all of you. We are at the first question right now. I hope it is visible. Okay, so let's begin the session. This is question number 1. A 4-stroke engine have a brake power of 10. It is 105 kilowatt. I think some problem here. It's 105 kilowatt. Supplied with a fuel at a rate of 4.4 per 10 minutes. The brake specific fuel consumption of the engine is. How to find the brake specific fuel consumption? The brake specific fuel consumption is given by the formula. It is equal to mass of the fuel to the brake power. Okay, I don't think it is 10 power 5. I think it should be 105 kilowatt. Let us check. Mass of the fuel is in 4.4 per 10 minutes. Now, in order to find in kg per hour, the unit is kg per kilowatt hour. This has to be converted into kilowatt hour. So this is 4.4 per 10 minutes. Okay. In order to convert into hour, what you have to do? You have to multiply with 60. Okay. Divide by 105. Just solve it. I think you will get the answer. This is given in kilowatt already. I think you should get the right answer. Just let me know. Okay, just a second. Let me check. I think per 10 minutes. So this will be 4.4 per 10 minutes. 4.4 divided by 10 into 60 kg per hour. If you solve it, you will get the answer now, I think. Yeah, so you will get 0.25 kg per kilowatt hour. Are you all getting this value? Okay, so we have converted this into, firstly we have converted this value into kg per hour. Okay, so in order to convert that into kg per hour, what we have done, we have multiplied with 60. 4.4 per 10 minutes. Okay, that is 0.44 minutes we have converted into per 10 minutes, hence you have to multiply with 60. Okay, not 6, multiply with 60, Arjun Nishant. Okay, so if you multiply with 60 divided by 105 kilowatt, you will get the value in kg per kilowatt hour. Okay, next question. A single acting two-stage compressor with complete intercooling delivers air at 16 bar. Assume an intake state of 1 bar and 50 degrees Celsius. The pressure ratio per stage is equal to. It should be multiplied by 6. No, it should be multiplied by 60, Arjun Nishan. Now, so we are having two-stage compressor. Two-stage compressor, that is compression is done in two stages. In the first stage, the compression is done from pressure P1 to P2. In the second stage, the compression is done from pressure P2 to P3. The pressure at the delivery is equal to 16 bar and at the intake or suction is equal to 1 bar. You have to find the pressure ratio per stage. That means you have to find P2 by P1 is equal to P3 by P2. The pressure ratio per stage you have to determine. Because it is complete intercooling, for complete intercooling in the two-stage compression, for complete intercooling, there is the pressure ratio between the stages becomes equal. That is P2 by P1 will be equal to P3 by P2. So from here you will get P2 is equal to geometric mean of P1, P3. Solve it, you will get this value as 1 into 16, which is equal to 4 bar. Now, you have to find the pressure ratio between the stages. So this will be equal to P2 by P1. P2 is equal to 4. 4 by 1 is equal to 16 by 4. That is 4:1. Okay, so the answer will be option C. This will be the pressure ratio. Clear? Next question. If a flow through the steam nozzle, enthalpy of the steam at the inlet to the nozzle is 3200. While ideal enthalpy at the exit of the nozzle is 3000 kJ per kg. And the nozzle efficiency is 90%. Find the velocity at the exit of the nozzle, neglecting the inlet velocity. Yeah, how are you going to solve this question? Just a second, I think there's too much of lag. Yeah, we are now at question number 3. In this question, first of all, you need to understand what is the formula for nozzle efficiency. Nozzle efficiency is equal to ratio of enthalpy drop actual in the nozzle to the isentropic enthalpy drop in the nozzle. Now what is the actual enthalpy drop in the nozzle? That is equal to H1, enthalpy at the inlet of the nozzle, to the actual enthalpy at the exit of the nozzle divided by H1 minus H2 isentropic. Okay. Now, in this question, nozzle efficiency is given. So you have to find the delta H actual. So velocity at the exit of the nozzle, you have to determine that will be equal to square root of 2000 into delta H. But that delta H will be actual enthalpy drop. Actual. And how you will find the actual enthalpy drop? Actual enthalpy drop will be equal to nozzle efficiency into enthalpy drop isentropic enthalpy drop. Okay, so just put the value. Exit velocity will be equal to square root of 2000 into nozzle efficiency into enthalpy drop isentropic. Now put the values, you will get square root of 2000 into 0.9 into 3200 minus 3000. Solve it, you will get the answer. What value you are getting? Tell me. 6 centimeter per second. Are you all getting 6 centimeter per second? Tell me, everyone. Whenever you get this nozzle efficiency, always remember that you have to then find the value of actual enthalpy drop in the nozzle. Okay, you have to find the actual enthalpy drop, then only you will be able to solve the question. Clear? For a gas turbine plant working on the Joule cycle produces 5000 kilowatt of power. If its work ratio is 50%, the power consumed by the compressor is. For a gas turbine working on Joule cycle or Brayton cycle, Joule cycle is also known as Brayton cycle, the work ratio is equal to 50%, and this power, what is this power? The power is the net power. The net power or net work is equal to 5000 kilowatt, and the work ratio, you know what is work ratio? Work ratio is equal to ratio of the net work to the turbine work. This is the formula for work ratio. So in this question, since the value of net power is equal to 5000 kilowatt, then turbine work you can determine from here. Okay, so turbine work will be equal to 5000, which is the net power, divided by 0.5, which will be equal to 10,000 kilowatt. Okay, now we know the turbine work, we need to find the power consumed by the compressor. So we know the one more formula, that net work of a gas turbine power plant is equal to turbine work minus compressor work. So compressor work will be equal to turbine work minus net work. Turbine work is equal to 10,000, net work is 5000. So you will get value as 5000 kilowatt. Okay, option C. Are you all getting? For we have to find the value of compressor work, not the turbine work. Okay, so 10,000 will not be the answer. The answer will be 5000 kilowatt. Yes, MS has given 10,000, Renault Meti has given 5000, Sagar Kumar, option C. Okay, please check your calculation, what mistake you have done. See, they have asked you to find the value of power consumed by compressor, or you have to find the compressor work. Okay, which will be turbine work minus net work. Firstly, you get the turbine work from this formula, then you get the compressor work. Next, in an axial flow compressor stage, air enters and leaves the stage axially. That is what we study about the axial flow compressor. The flow is parallel to the axis of the compressor. Okay, if the whirl component of the air leaving the rotor, what is rotor? Rotor is the moving blades of a compressor. On the rotor we have moving blades, is half the mean peripheral velocity of the rotor blades. Whirl component of the velocity is whirl component VW2. This is called as exit whirl velocity. The whirl velocity at the exit of the whirl velocity at the exit of compressor, and mean peripheral velocity. This is denoted by U2. Mean peripheral velocity. Okay, mean peripheral velocity is equal to U2 here. So what is degree of reaction? Degree of reaction, you know the formula, it is degree of reaction is given by 1 minus VW2 divided by 2U2. So in this question it is given that the world velocity, what is given? World velocity is half of blade velocity. So if it is half of blade velocity, this will be 1 minus 1 by 4. That will be 3 by 4. So you will get 0.75 as the answer. Okay? Are you all getting this value? So this is the formula for degree of reaction of a compressor where world velocity and blade velocity are given, or any relation is given between them. Okay? In this question, the relation is world component is half of the mean peripheral velocity of the blades. Clear? Next question. Determine the heat rejected in kilowatt from a heat engine functional on Carnot cycle. There is a heat engine which is working on Carnot cycle. You have to find the heat rejected in kilowatt, which takes in the heat at the pace of 40 kilowatt from a reservoir at 1200 Kelvin and rejects it to a sump at 300 Kelvin. So basically in this question they have given the high temperature reservoir which is at 1200, low temperature is at 300 Kelvin, the heat which is supplied, which takes in heat at the rate of this. So this is the heat supplied, 40 kilowatt is the heat supplied. You have to find the heat rejected. Now for Carnot cycle, you know that for a Carnot cycle, the heat supplied by temperature at heat supplied is equal to heat rejected to the temperature at which heat is rejected. Heat supplied is 40, temperature at which heat is supplied is 1200, heat rejected, to find temperature at which heat is rejected is 300. So this 2 zeros will get cancelled out, this will be 3 4 the 12, the heat rejected will be 10 kilowatt. Okay, you can use this relation for a Carnot cycle. If there is a cycle, if it is a reversible cycle, we can use this relation. Okay, the heat supplied divided by temperature heat supplied is equal to heat rejected to the temperature heat rejected. This is formula we can use. Next question. I hope the diagram is visible to all of you. If not, let me just look so clumsy. Let me just increase the diagram is not so clear. So let me just put it here. Is it clear now? I hope it is clear to all of you now. I hope I am also visible in this diagram. So if you see, there is a temperature and entropy diagram, and they are asking you to tell that on this diagram, temperature entropy diagram, how you represent the adiabatic, isoporic, isobaric and isothermal process. First of all, we need to understand that on temperature entropy diagram, that is very obvious that temperature entropy diagram, the constant temperature process will be shown by horizontal line and isentropic process will be shown by vertical line. Vertical line will represent isentropic process or reversible adiabatic process. Okay, so vertical line here are, these two are vertical line. This is 2, process 2 will be isentropic. Isentropic means constant entropy. Constant entropy means reversible adiabatic. And horizontal line, this is 1. This is constant temperature. Okay, so 1 is constant temperature. Adiabatic is represented by 2 and isothermal by 1. So 2 and 1. 2 and 1 will be correct. So this and this will not be the answer. Now let's talk about the constant pressure and constant volume. On temperature entropy diagram, we know the relation between constant temperature volume and constant volume and constant pressure. Constant volume has always higher slope than constant pressure on temperature entropy diagram. Which has more slope? Constant volume. So if you see, the next two diagram are this is 3, this is 4. If you see, this is a horizontal line with horizontal, this is a theta slope, which will be having more slope. Which has more slope? Constant volume has more slope. So this will be constant volume, this is constant pressure. So constant volume will be 3. 3 will be constant volume and this will be constant pressure 4. 2 3 4 1. 2 3 4 1 is option C. Clear? Is it clear? Is it clear to all of you? Tell me. Always remember this thing, that on a temperature entropy diagram, temperature is shown by horizontal line, entropy is shown by vertical line, constant entropy by vertical line, constant volume and constant pressure are shown by curved line, which has more slope, theta, that is slope of constant pressure will be more than constant volume will be more than constant pressure. The efficiency of any heat engine and efficiency of a reversible heat engine operating between common heat source and heat sink are related as. Those who have joined me for this session and not yet, you have not shared the session or liked the session, it has been a habit of that every Monday I request all of you to do that. Not every Monday, every day, whenever I take the session. So I can see the subscribers, it's 915. Channel was started. We have started this RRB JE channel, I think from in the month of August. In August only we have started. It has been more than a month and we have not yet reached 1000 subscribers. Request everyone to share this YouTube channel with your friends so that they can join this channel, they can get benefited. Also, those who have joined me for this session, please do not forget to like and share the session. You know what is Carnot principle? Carnot principle says there are two Carnot principles. The first one being that if between the same source temperature and same sink temperature we are having a reversible engine and an irreversible engine, and irreversible engine, then which will be having more efficiency? Here, efficiency of the irreversible will be less than efficiency of reversible. And between same common heat source and common heat sink, if we have all the reversible engine, then efficiency of the reversible engine working between same temperature will be same. Why it will be same? It will be equal to 1 minus lower temperature by higher temperature. So if it is any engine will be, it can be reversible or irreversible. Its efficiency will be less than or equal to efficiency of reversible engine. So the answer will be option D for this question. And I can see Renault and MS, if you have given the answer for this question, then your answer is correct. Have you given the answer for this particular question? Your answer is absolutely right. Next, a new temperature scale A is proposed such that the boiling and freezing point of water at the atmospheric pressure are 200 and 500 respectively on this new temperature scale. The reading of 5 on this new scale corresponding to which of the following reading on the centigrade scale? I hope you understand this kind of temperature questions related to temperature readings are also comes in the exam. So we have a new temperature scale called degree A scale. On this scale, ice point, also known as freezing point, and boiling point, also known as steam point, are given to you. What is the boiling point here? 200 degree A. What is the freezing point or ice point? 50 degree A. Now they are asking what will be the reading on this scale corresponding to, if on this scale the reading is 5 degree, if this is 5 degree, then what will be the reading in the degree Celsius scale? Are you getting this? On the degree Celsius, the boiling point and steam point, ice point and steam point you already know, 0 and 100. So here you will apply simple formula, degree Celsius scale minus ice point divided by steam point in degree Celsius minus ice point is equal to degree A scale minus, what is the ice point? 50 to the boiling point, which is 200 minus 50. Now if you solve this, this will be degree Celsius by 100. What is this value? 5 minus 50 by 150. If you solve this question, you will get the answer. Degree Celsius by 100 will be minus 45 by 150. This will get cancelled out. Degree Celsius will be equal to minus 450 by 15, that is minus 30. Okay, so when the reading on this new scale, which is known as degree A scale, will be 5 degree, then on Celsius scale it will show the value of minus 30. This question is very similar, like asking you like if your friend or relative or any lives in UK or USA, let's say different time zone, and let's say you are you have to talk to that person through you are having a WhatsApp call to that person in the evening at 6 p.m. So maybe if you are talking to a person in USA or UK, the time zone will be different. Okay, so you can easily calculate the time difference on the Google also, that okay, this is 6 p.m. in India, so what will be the time in US? Very similar to that, we can compare the temperature reading in a particular temperature scale like A scale with the degree Celsius scale like this. A 3-stage compressor having perfect intercooling in each stage. If the pressure at the end of third stage is 64 and the pressure at the inlet of compression is 1 bar, then what will be the pressure at the entry of second stage? Okay, so thank you so much to all the 5 students who think that this session is worthy for. Thank you so much all the mechanical engineers and diploma students. Only 5 mechanical engineers and diploma students who are watching the session. It means a lot, because coming live to the session at 8 p.m. night, it's so much difficult, right? You have to go to your office, you are at this point. Some of you have to go to college. It's difficult to attend the session live at 8 p.m. So I can understand only 5 students are free right now. Rest are busy in their job and their college. You know? That's why I have scheduled this session at 8 p.m. so that all the students should basically attend these classes. But looks like for some of the students, maybe the office timing is up to 10 p.m. after that, so they are not able to attend the classes. So it is a 3-stage compressor. This is first stage, this is second stage, this is third stage. All right. In this question, it is saying the pressure at the end of third stage. End of third stage is this. This is 64. P4 is 64, and at the inlet is equal to 1 bar. Inlet of the compressor is 1 bar. They are asking what is the pressure at the entry of second stage. Entry of second stage is this. This pressure they are asking this question. How to find this? You can directly use this formula. P4 by P1 is equal to P2 by P1 ki power 3. Simply you can use this formula. P4 is 64 by 1 is equal to P2 by 1 power 3. You will get P2 is equal to 4 bar. I think all of you have used the same technique, 4 bar. But if I ask you, okay, tell me what is the value of P3? Can you tell me the value of P3? Yes, I think you can tell the value of P3 because it's very simple. The pressure ratio will be same in each stage, right? So P3 will be equal to P2 into P2 divided by P1. It will be 16, right? So be ready for these kind of questions. For perfect intercooling in a compressor, the pressure ratio in each stage becomes equal. Okay. So if you know the value of P2, you can get the value of P3. P4 you already know. A single acting reciprocating pump running at 75 RPM delivers 0.50 meter cube of water per minute. If the diameter of the piston is 160 mm and stroke length is 350 mm, then percentage slip of the pump is. What do you mean by percentage slip? You have to find the slip, but they are asking percentage slip. Percentage slip is difference of the theoretical velocity minus, discharge minus actual discharge by theoretical discharge into 100. This is the formula you can use for finding the percentage slip. Now in this question they have given this discharge. What is this discharge? They have given the actual discharge in this question as 0.50 meter cube per minute. You have to find the value of discharge, which is also known as theoretical discharge. Let's find the theoretical discharge. Theoretical discharge will be A into L into N by 60. You can use this formula, you will get the value of theoretical discharge. Find the value of theoretical discharge. Just put in this formula and you will get the answer. Tell me the answer quickly. If you need some more time to solve this question, you can take it. We have plenty of time. Okay. Five students live in the session. Okay. All right, done. Just a second. Here they have given the diameter of the piston. Diameter is the bore. You can write pi by 4 d square into L into N. Now divided by 60. If you divide by 60, the answer will be in meter cube per second. So because they have given the discharge in meter cube per minute, what you can do is you don't need to divide by 60. Okay, you can directly write ALN, that is area into stroke length into speed. Okay, so don't need to divide by 60, just put the value pi by 4 into d square, which is 0.16 square, into stroke length is 0.35 into 75. Okay, solve this. You will get meter cube per minute and you will get the answer. 5.56. Some of you are getting 5.56. Let me also solve. 0.7854. Use calculator. There is no problem of using calculator here, because in your exam you can use calculator. So you will get this value as 0.527 meter cube per minute. Okay, 0.527 meter cube per minute. Just put the values. You will get okay, just a second. You will get this as theoretical is 0.527 minus 0.50 divided by 0.527 into 100. Okay. So you will get 5.27%, which will be option C. Okay. Are you all getting this value? Tell me. Some of you are getting option D as the answer. Sagar is getting option D. Why option D? Is it not 5.27? Any mistake? 1.16, 0.35, 75. Option C will be the answer. Next question. A reservoir has head of 50 meter and the flow rate for the turbine is 36 meter cube per second. If the runner speed is 180 RPM and the overall efficiency is 92%, then which type of turbine will be this? Can you tell me the type of turbine based on this data? So we can classify the turbine based on the specific speed. Specific speed is equal to n root p h ki power 5 by 4. Okay. If you know the specific speed, you can classify the turbine. In this question, they have given the speed of the runner. They have given the head, but you don't know the value of power. Do you know the value of power? No. But overall efficiency is equal to shaft power, or we can say simply power divided by rho g q h divided by 1000. From here you will get the value of power. The power will be equal to overall efficiency into G into Q into H. Okay, just find this value in kilowatt. Just put the value in kilowatt power and you will get the value of specific speed. Hello Ankit Singh, namaste, good evening, welcome to us. Those who are joining me for the first time, then please do not forget to like and share the session and subscribe the channel. So you will get this value as 16.245 kilowatt will be the value of power. You will get this as 180 into square root of 16.245 divided by h. H is 50 power 5 by 4. From here you will get a specific speed. Or based on the specific speed you can classify the turbine. Tell me. Oh, just a second. Are you getting 5.4? I think some mistake here I've done. This value will be directly in kilowatt, not point. This should be 16245 only, no? It's only 16245, not 16.5. This much specific speed is very less. Just a second. Felton is not given. Impulse is given. Impulse specific speed. In the formula, the power is in kilowatt. Generally, the power is in kilowatt. So, just a second. No? Okay, so now the specific speed comes out to be very high. We'll get very high specific speed. It will be 3068.4 RPM. So that will make it Kaplan turbine. Are you all getting Kaplan as the answer? Okay. Are you getting Kaplan as the answer for this question? I think some mistake is there. इतनी ज़्यादा specific speed नहीं आएगी. Either I'm doing some calculation mistake. The value you will get in kilowatt. If this will be in kilowatt, 16245. Just a second. Oh, sorry, my mistake. It will be 172.5. 172.55 RPM. So 172.55 is a specific speed for which type of turbine? Yes, is this specific speed for a इतनी बेस कैलकुलेशन की क्या बेसिस नहीं है की जरूरत क्या है के बेसिस पे भी तो चूज कर सकते हैं विच के यू आर टॉकिंग अबाउट हेड के बेसिस पे हाँ हेड के बेसिस पे कर सकते हैं 50 मीटर हेड 50 मीटर हेड कैन बी फ्रांसिस ऑल्सो specific speed greater than 172 is will be Kaplan turbine. Okay, next, which of the following processes are irreversible? Heat transfer through a finite temperature difference, free expansion, transfer of electricity through a resistor, which will be irreversible process. Now based on the head you can do the calculation, but head is 50 meter. As per that 50 meter head is there, so it can be Francis also. It can be Francis also as based on the head. Okay, it can be Francis and it can be Kaplan, so it can be both. So we have to check the specific speed 172.5, so it will be Kaplan based on the specific speed. Heat transfer to a finite temperature difference, free expansion, transfer electricity, all these processes are irreversible. Okay, all these are irreversible process because temperature difference is there, then external interaction. Due to external interaction the entropy can increase. Okay, due to heat transfer the entropy can increase. So entropy depends on the total entropy change or irreversibility depends on heat transfer plus entropy generation. Okay, entropy generation is because of free expansion, friction, throttling, and heat transfer. This is due to temperature difference. Okay, all these can increase the entropy. Transfer of electricity through a resistor, that is also irreversible process. Now this is an assertion reason type question. All the constant entropy processes are adiabatic, but all the adiabatic processes are not isentropic. All the constant entropy processes are adiabatic, but all the adiabatic processes are not isentropic. This is not correct, that if the entropy is constant it will be adiabatic. This is wrong. An adiabatic process which resists the exchange of energy to the surrounding may have irreversibility due to friction and heat addition. See, entropy change is equal to Q by D plus entropy generation. An adiabatic process which raises the heat exchange of heat to surrounding. Why? Because if the process is adiabatic, the entropy change can be equal to entropy generation. In that condition, the entropy can increase, or irreversibility or entropy can be because of friction, free expansion, all these things. So yes, that is correct. If an adiabatic process there, it is definitely correct that there will be no heat transfer to the surrounding, no heat exchange with the surrounding, but there will be irreversibility because of friction and some other reasons like free expansion, like throttling. Okay, the first process, all constant entropy processes are adiabatic. No, that is not correct, because in irreversible process, when heat is rejected, then entropy change can be positive, negative, or zero. That means entropy change can be zero for, or it can be isentropic process for irreversible process also, and it is not necessarily it will be adiabatic. So this statement is wrong. So the answer will be option A is false, but R is true. Assertion is false, reason is true. Next question. इतने सारे मैकेनिकल इंजीनियर्स को देख के मेरी आंखों में क्या ही बोलूं मैं, क्या हो गया। मैकेनिकल में 5 बच्चे, अगर if let's say RRB JE students in the, let's say 15 lakh forms have been filled, okay, let's suppose a number. In 15 lakh forms, obviously there will be at least 5 lakhs mechanical engineering students. And 5 lakh students, 5 students at Resultant, which is not so much of new channel because 916 people are there. I'm also sharing this video on different telegrams. Maybe all of you must be sharing this video. So 5 students is such a big number, na? It looks like where सारे बच्चे कहाँ चले गए भाई? 1 kg of air is subjected to the following process. Air expand isothermally from 6 bar to 3 bar. Air is compressed to half its volume at constant pressure. Heat is supplied to air at constant volume till its pressure becomes threefold. In which of the above process the change in entropy will be positive? Entropy change will be positive. Let's see the first process. In the first process, you know that we are talking about air or gas. Entropy change is equal to Cp log T2 by T1 minus R log P2 by P1. Because it is saying that it is isothermally, air expands isothermally, so that is temperature T1 is equal to T2. T1 is equal to T2, so this log 1 will become 0, so entropy change will become negative. Okay, it will become negative or positive from 6 bar to 3 bar. Okay, sorry. No, it will not be negative. Why? Because this will be, entropy change will be equal to minus R log P2. What is P2? 3, P1 is 6. So this will be minus into minus plus. So entropy change will be positive. So here the entropy change will be positive. Air is compressed to half the volume at constant pressure. अच्छा 2 दिन पहले पता चला हम आए यूट्यूब पे, मुझे तो 1 महीना हो गया अंकित. इट हैज बीन मोर देन अ मंथ, बट चलो अच्छी बात है, यू गॉट टू नो नाउ आई एम ऑन यूट्यूब. इफ यू सी ऑप्शन नंबर 2, in option number 2 you can use this formula of entropy change. It is Cp log V2 by V1 plus Cv log P2 by P1. If you use this formula, you know that air is compressed to half the volume at constant pressure. If pressure is constant, this will be 0, and if volume is half, this will be negative. If volume is V2 is equal to half of V1, this will be negative. So this is definitely not the answer. Second is not the answer, so second options, which is the right answer, will be option C. Clear? Is it clear to everyone? Heat is supplied to air at constant volume till its pressure becomes threefold. Same question. If volume will be constant, this will be 0, and pressure become threefold. So P2 is equal to 3 times P1. Okay. So entropy change will be positive. Okay. Next question. Consider the following statement. When dry saturated steam is throttled from a high pressure to a lower pressure, the pressure decreases and the volume increases. Temperature decreases and the steam becomes superheated. The temperature and dryness fraction increase. Entropy increase without any change in enthalpy. Let's see the Mollier diagram. On the Mollier diagram, if you see, it is mentioned that steam is throttled from dry saturated steam. Dry saturated steam is here. At this point, we have dry saturated steam. Okay. Now, this dry saturated steam is getting throttled. Throttle is constant enthalpy process. At this particular point 1, we are doing throttling. Constant enthalpy process done. Okay. Second के लिए तो कुछ कर रहे हैं अंकित. We are providing you these questions. These questions, what do you think that? What as a teacher I can do? I can provide you lectures. I can take sessions. These are free sessions. We are providing paid classes also. So in the free classes, you can see that we are providing you these questions, which are not only for RRB JE, obviously. It is only also for SSC JE CBT2. The reason these are title based on RRB JE 2024, if you see the thumbnail, it will be RRB JE 2024, because we are providing you courses only for RRB JE. Because this is a new platform, we have not provided any classes for SSCG CBT1 because this resultant has started AG from August. So we cannot write SSCG CBT2 because we don't have any course for that. So we are not promoting SSCG CBT2 because we don't have any course. Yes, if you follow these classes, your preparation for SSCG CBT2 and RRB JE CBT2 both will be there. Okay, I guarantee you. Okay. So just attend these classes. That is the best I can do. That is the best you can do. All right. So this is a Mollier diagram. Now see this diagram. Because throttling is there, what is the meaning of throttling? Let us say this is P1, P2, P3, P4, P5. Throttling means pressure will reduce, right? Pressure decreases. Now pressure decreases. What is happening to volume? Volume will increase, right? Obvious phenomena, if pressure decreases, volume increases, this is correct. Temperature decreases and the steam becomes superheated. Temperature decreases, this is also correct. Temperature transmission increase, this is also correct. But I have a doubt on this first option. Entropy increases without change in enthalpy. So if you see the first option, they are saying pressure decreases and the volume increases. We cannot say anything about the volume here. This thing about volume, this is not correct. Okay, we cannot say that volume will increase, but we are sure that pressure will decrease. So this is not 100% correct. Temperature decrease and the steam becomes superheated. This option is incorrect. Third option is incorrect because temperature is not going to increase. Temperature will decrease. Pressure will decrease, so temperature will decrease. Dryness pressure will increase. Steam becomes superheated. Steam becomes superheated. Okay? Superheated. So this is correct. This is not correct. This is correct. What can be said about the first option? Option 2 and 4 is 100% correct. What about the first? Tell me. See, although we know that pressure is going to decrease for sure. If pressure will decrease, what will happen to the volume? Well, the volume will increase in throttling. Because throttling is basically a expansion process. In the expansion, on a pressure volume diagram, if expansion is happening, how you classify the expansion? In expansion, pressure will reduce, volume will increase. So according to that, yes, option 1 can be correct. Okay. Although from the given, from this Mollier diagram, you cannot comment on that. 170 kJ of heat is supplied to a system at constant volume. Then system rejects 180 kJ of heat at constant pressure and 40 kJ of work is done on it. System is finally brought to its original state by adiabatic process. If the initial value of internal energy is 100 kJ, then which of the following statement is correct? (170 kJ is heat supplied to a constant volume. The system rejects this much amount of heat at constant pressure. Okay. So basically we are having three processes in this question. On a pressure volume diagram, firstly, heat is supplied at constant volume. Heat is supplied at constant pressure volume. Then system rejects heat at constant pressure. Rejects heat at constant pressure. All right. And then adiabatic. Okay. This and this, like this diagram will be 1 2 3. Clear? Firstly constant volume, then constant pressure, then adiabatic. Okay, so this is all the three processes. Now what they are saying, the highest value of one more thing, it is mentioned in the question, 170 kJ of heat is supplied system at constant volume. So here the heat supplied is equal to 170. All right. The system rejects 180 kJ of heat at constant pressure. 40. Okay. in this process, 2 to 3 process, the heat rejected is equal to minus 180 because it is rejected, and work is done on it, so it will be minus 40. And third is adiabatic. Okay. In order to solve this question, my dear, I need one more page because on the single page this question cannot be solved. So I need one blank slide in order to solve this question. So because I have drawn the cycle, and how the cycle is like this: PV, constant volume, then constant pressure, and then adiabatic. 1, 2, 3, 1. Now, since this is a cycle, and for a cycle, net heat is equal to net work. Right? Now, for this process 1 to 2, the heat transfer is Q1 to 2 plus Q2 to 3 plus Q3 to 1 is equal to W1 to 2 plus W2 to 3 plus W3 to 1. This is one way of solving this question. In this process, the heat transfer is plus 170. This process, the heat transfer is minus 180. Constant pressure. And this process will be adiabatic because this is adiabatic. Clear? Work in the first process will be 0 because this is constant volume, work will be 0. In the second process, the work is minus 40. The third process, you can find the work. Tell me everyone. This will be minus 10 is equal to minus 40 plus work 3 to 1. So work 3 to 1 will be equal to plus 30. You know that for this adiabatic process, heat transfer will be 0, but work will be coming out to be positive. Clear? Also, it is given one more thing. Initial internal energy is equal to 100. That means at this point, initial internal energy is equal to 100 kilojoule. Clear? Now let's see all the options given. The highest value of internal energy occur at the end of constant volume process. Okay, let's see how they are saying this. Highest value of internal energy occurs at the end of constant pressure process. Highest value of internal energy occurs after adiabatic expansion. Internal energy is equal at all points. Which will be the right answer? Tell me. Will internal energy will be equal? For a cycle, cyclic integral of internal energy will be equal to 0. Okay. So if you just add this, U2 minus U1 plus, see, we can solve this question also. It will become very big question. We can solve it also because for constant volume process, for 1 to 2 process, if you apply the first law of thermodynamics, Q minus W is equal to du, the heat transfer for the first process is equal to 170. The work is 0. Tu will be equal to U2 minus U1. U1 is equal to 100. So U2 will be equal to 270. Okay. So at this point, internal energy will be equal to 270 kilojoule. Clear? Can you find the internal energy at this point? Tell me. You can do that. I think I have taken a very big question. It looks like it is a very small question, but it's not. For 2 to 3 process, Q minus W is equal to du. The heat transfer at point for constant pressure process is minus 180. The work is minus 40. It is equal to U3 minus U2. So this will be minus 180 plus 40. So minus 140 is equal to U3. U2 is equal to what? 270. That is minus 270. If you solve it, you will get U3, that will be equal to 130. Okay. That means this internal energy will be 130. So highest, till now the highest is at point number 2 at the end of constant volume. The highest value of internal energy occurs at the end of constant volume. Option A can be the answer. But there is one more option, expansion. Here it is adiabatic expansion. Tell me, after expansion the energy will be, this is 100. So here it is 100, this is 270, this is 130. So the right answer will be option A. Clear? Clear to everyone? Little bit lengthy question, I'm sorry. I think I should have not taken this question. A 4 kilowatt 20 liter water heater switch on for 10 minutes. The heat capacity for the water is 4 kilojoule per kg Kelvin. Assuming all the electrical energy has gone into heating the water, the increase of the water temperature is. So how you are going to solve this question? Looks like students are leaving the session. You don't want to solve these questions? Should we end the session? Okay, I think time is also over. Let's end the session. Rest of the question will be solved tomorrow. I will make sure that tomorrow I will not take such a lengthy questions. Students start to run from the session. Thank you so much. I will see you tomorrow at 8 p.m. Thank you so much. Have a nice day. Thank you.